Now, it is important to think of volume instead of just dimension. Now, let me try to explain why tumor is important and illustrate it. Now, if we have a tumor that's perfectly round, and if the diameter is 4 centimeters, you can calculate it, and the tumor volume is 33.5 cubic centimeters. Now I'm going to ask you just to imagine, if the tumor is 5 centimeters in diameter, is it a small increase or a big increase in tumor volume? The tumor volume is actually double. Now this is a very important thing to note. From 4 centimeter to 5 centimeter, the volume actually has doubled. Doubling is a tremendous increase. Now, if you earn $100 a day, and if your new pay is $200, there's a lot of difference. It's doubling. If you have $1 million to buy a house, and if you look at the next house is $2 million. That's a big difference. So tumor volume gives a more accurate idea of how many malignant cells you need to deal with when you are having treatment. And the other thing is that tumors are not round like what I've shown you. The word cancer comes from crab in Greek or Latin, I think. So it's very irregular in shape. Now, if you want to measure the diameter, which diameter do you measure? There are lots of different types of diameter. So when you measure diameter, it doesn't really give you the idea of how many malignant cells you have to deal with. So the idea here is try to measure the tumor volume. Now let me give you some examples of what we have done in our research work in measuring tumor volumes and how we can come up with certain algorithms to do it. Let's look at this tongue carcinoma. The diameter is 3.7 centimeters. We measure it with our software. It is 12.1 cubic centimeter volume. We have another patient. The diameter is 3.4, but when we measure the volume, it is 17.1. So measuring diameters is somewhat misleading. Some diameters that be shorter, but actually the volume is much bigger. So what we did in Singapore was we decided to work on how to actually measure the volume. The reason why I went into this particular research is because I'm actually part of the UICC TNM staging expert committee. When I begin to see the literature coming out to talk about how important tumor volume is, I thought maybe I should do some research work on how to measure the volume, because if you don't have a method of measuring volume, you can't compare. If you measure it this way, I measure another way, it's very difficult to compare. Let us try to find a method of doing it. And I managed to get a grant, and we did publish some preliminary work, and this is one of them that we published in Radiology. One of the methods that we can use is to first of all try to figure out what are the signal intensity of all the various tissues around. And then after giving contrast, we try to segment out the tumor volume. So in this particular one, we may just press a segment, segment it to give you the volume. So this particular section, the volume here, you can say that is 4.4 cubic centimeters. So we can do other forms of measuring. These are taken from the software we've written. We can make a sort of a circle around it, get a computer to calculate the volumes. We can put it within the tumor and let it expand outwards, and you can get the volume. And from measuring the volume, we went on to work of how to correlate the tumor volume and a TNN system of the T1, T2, T3, and T4 and try to derive some characteristics or correlationship.